So double angles. So this first one, we know the cosine of 120 degrees. Alright, so since it's a double angle, alright, the formula for the cosine of a double angle would be 2a. So if you want to, you could do it this way. So I need to figure out what a is, because a is going to, in my formula, it's cosine squared a minus sine squared a. So I need to know what a is. All right, since it told me to use a double angle. This is what I'm given. This is what I want to find. I need to know what a is before I can go any further. So you can set what's on the inside here and here equal to each other to find out what a is. So if I divide both sides by 2, a is equal to 60 degrees. So once we found a, we can plug that into the formula. And so the cosine squared of 60 degrees minus the sine squared of 60 degrees. So on your test, even though we know the cosine of 120 degrees, if this problem were to be on there, I would still want you to show me this. So, what is the cosine of 60 degrees? So it is 1/2. So we would have 1/2 squared minus the sine of 60 degrees. So the sine would be root 3 over 2 squared. And since it's cosine squared of 60, that value is squared. Sine squared of 60, this value is squared. So we'll go up underneath there. What's 1/2 squared? I should be able to. 1/4. Root 3 over 2 squared would be what? 3 over 4. Then 1/4 minus 3 over 4 would give me negative 2 over 4, which is negative 1/2. Okay, so I'm going to answer that as we go over. Or see if I do. So we need to know what a is to be able to use the formula. So 2a is equal to 4 pi over 3. And if I divide both sides by 2, if I divide by 2, it's the same as multiplying by what? 1/2. So if you want to do that, it's going to just save you from having to do the ear. So if I multiply both sides by 1/2, those 2's cancel. And a is equal to 4 pi over 6, which is the same as 2 pi over 3. Now that we know what a is, it's 2 pi over 3 or 120. It doesn't matter which one we use. So we got the sine of 120 and the cosine of 120. I don't want to write sine again. What is the sine of 120? So it's the y value at 120 for the sine, the x value at 120 for the cosine. Now we just have to multiply all this together. This 2 and one of the other 2's will cancel out. So we're just left with 1 on the bottom, 1 there. So root 3 times negative 1 gives me negative root 3. And then 1 times 2 on the bottom gives me 2. So negative root 3 over 2 is the sine. The cosine of, or 165 degrees is not on your unit circle. as far as one of the degree values go. Like it's not one of those that we write in on the unit circle. So this is where that formula comes in handy. We're going to use the half angle. Alright, so if we use the half angle, we're supposed to do what to the angle it gives us? We got to double it. We got to do the opposite of basically what you would think, maybe, when it tells you half angle. So if we got to double it to find A. So we want A to be not 1. So when you double something, you can just multiply it by 2 or add it to itself, whatever you're comfortable doubling with. The way I would double that quickly in my head is 160, and 160 is 320, and then 5 and 5 is 10, so that'd be 330. Try to help you with your mental math there. You can split that up.
Wait, so we're doubling?
Cosine of theta over 2, or A over 2, whatever your formula says, is 1 minus the cosine. I think that's supposed to be a plus. It is. Somebody marked on it. 1 plus the cosine of theta over 2. So I guess since I used A, I'll just use A here. It doesn't matter what variable you use. It won't bother me at all. Alright. So now I'm going to plug what I'm using for A into the formula. And that's the important part. This right here is when I plug this in, I need to make sure that it gives me 165. And 330 divided by 2 is 165. So it's going to give me what I want. Then I got plus or minus the square root of 1 plus the cosine of, I'll zoom out in a second, 330 degrees all over 2. So from here, the cosine, 330 divided by 2 is 165, which is what we wanted to get from the problem it gave us. Plus or minus the square root of 1 plus. So the cosine of 330 is root 3 over 2, and then over 2. And this whole thing's under the root. So don't forget that. The whole problem's under the square root. So common denominator is 2. We change 1 to 2 over 2. Then from there, when we add fractions, we don't add the denominator. So the denominator is 2, and we'd have 2 plus root 3 over 2 over 2. Why won't these 2's cancel out? Because there's an addition sign at the top. Good. So my only option here is I want to do the ear. Okay. So outer ear goes on top. So that's 1 times 2 plus root 3. So that's just going to be 2 plus root 3. And on bottom, the inner ear, which is 2 times 2, is going to give me 4. Okay. Have a square root over an entire fraction, we can split the square root up. Square root of 2 plus the square root of 3 all over the square root of 4. That's all all over the square root of 4, which is equal to square root of 2 plus square root of 3 all over 2. Alright, now the plus and minus sign just doesn't disappear. Alright, we need to go back to our angle is, what was the angle that it gave us? Since it's not showing up here. What was the angle that it gave us? It's 165. What quadrant is 165 in? It'd be the second quadrant, because so since the cosine is negative in the second quadrant, our answer needs to be negative, and I can't really simplify that anymore. So that would be my answer. I'll zoom all the way out so you can see the whole problem. So same way as we always draw our triangles, we're going to start in the origin, and we're going to come out from the origin and connect back to the x-axis. I'm going to draw one the wrong way because there's several people that still did it wrong on the test. This it's not showing up still. I don't know what is wrong with this thing. Every angle we talk about from the unit circle, we're looking at the angle that is formed with the x-axis. So we're always looking at this angle. We can't, this angle is 90 degrees. That's not what we're looking at. Alright, this angle is 90 degrees, so there's no way to tell what angle I'm looking at. Some of you'd still get it kind of right, because you would still put those on the x and y axis and get the hypotenuse right. But this is the angle that it wants you to draw. Your college professor is going to want you to draw. Some of you still looked up and got the right answer here. But this is the type of triangle that we want to draw. Alright, so the next thing we need to do is we need to know what is tangent. In SOHCAHTOA, what is tangent? It's opposite over adjacent. Alright, so my tangent here is equal to 2. I need it as a fraction, so my fraction would be what? So it's 2 over 1. Alright, so now, that's opposite over adjacent. So this is why I wanted you to label the triangle on your test Monday, on the quiz you had Monday. The opposite side, because this is important, so opposite side's which one? This one here. Alright? Because you could do the SOHCAHTOA part, but then you didn't know what went where. And that messes you up on the sine and cosine. So opposite goes here, and the adjacent is 1, it goes along with the x-axis. In these triangle problems, the x-axis is always the adjacent side. Alright, so now is 1 and 2 one of the triples that you know or had to memorize? Alright, so I'm going to set that up. I have both legs. So it's going to be 1 squared plus 2 squared equals c squared. C squared is always the hypotenuse, so it's always that line that comes out from the origin. So if I had c squared and I didn't have one of these, I'd plug that in for c squared. And some of y'all take whatever two things it gives you, square them and add them together and try to find the other side. You can't do that. If one of those angles one of the things it gives you is the hypotenuse, you have to set it up like this and subtract 1 and then take the square root. But from here we're fine. So that's going to be 1 plus 4, which is 5. So c is going to be, that should look more like a 5. C squared is going to be the square root of 5. Can I break down the square root of 5? No. So that side's going to be the square root of 5. Alright. Oh, I didn't. Do I have anything to plug in for theta? Like, am I going to plug an actual value like 120 degrees in for theta? No. Theta is just representing this angle here that's formed between the origin, or the x-axis, and the hypotenuse. So we're really not going to plug a number in for theta. So really, the only place we're going to plug something in is cosine of theta. And the cosine of theta is just the value that you get from SOHCAHTOA. So using SOHCAHTOA, what is the cosine of theta? It's adjacent over hypotenuse, which is what? 1 over the square root of 5. Right? So now we can use that to plug it in to our problem. Alright, so just so I have more room. So I have plus or minus square root of 1 minus 1 square root of 5 over 2. Plus or minus, what have we got to do on the top? Common denominator, which will be what? Yes, it'll be root 5. Alright, so if you want to do kind of like what we did before, this is like my big fraction. On the top, root 5 is going to be my common denominator. Alright, this is what we did with the trig stuff before. Root 5 is going to be my common denominator. What do I multiply 1 by to get root 5 on the top? So root 5. And this one already has root 5, so do I do anything to it? No, so I keep that numerator the same, because I don't have to multiply this fraction by anything. I had to multiply this one by root 5 on the top and bottom. That's where that root 5 came from. Minus, then I didn't have to do anything to this fraction, so I kept whatever was on top. And that's what I get when I find the common denominator. And then the whole thing's over 2. So from there, what have we got to do? Ear. Alright, so outer ear goes on top, which gives me root 5 minus 1 over 2 root 5 Alright, then I could separate the top and bottom here. In fact, when I put the directions on your test, I'll tell you which ones I want you to rationalize the denominators on, because normally we wouldn't want square roots on the bottom. On the ACT, it'll want you to rationalize them. Something this big, I'm probably not going to make you rationalize. If you can get to here, then you're fine. Alright, so you can stop. You can stop here. Only thing is you need to tell me which one it is, plus or minus. We're in the first quadrant, so everything's plus. So just make sure you tell me which one. If it's plus or minus, then you can stop there. I'm not going to make you go any further, because that would take a while, and that's not really judging your pre-calc knowledge.